Okay, so I thought I would show you a couple examples just so you had something to practice with, examples of some sinusoidal motion. So the first one is a Ferris wheel. So I have this problem. It says the diameter of a large Ferris wheel is 48 meters, and it takes 2.8 minutes for the wheel to complete one revolution. Okay, so one revolution is the same as one cycle, one time around. So that's happening in 2.8 minutes. Okay, so that means 2 pi over b is equal to 2.8. And if I solve for b, I get 2 pi over 2.8, which reduces to pi over 1.4. So there's my b value. I also know that the Ferris wheel, if I draw the Ferris wheel, it says it has a 48-meter diameter. So this whole distance here is 48 meters. And that means that it's a little bit off the ground. Does it say how far off the ground it is? The lowest point, which is 60 centimeters above ground. Okay, so that little piece there is 60 centimeters above the ground. Okay, so let's draw this there. All right, so if we put it all in centimeters, 48 meters is how many centimeters? Okay, 48 meters is how many centimeters? Because we either have to do it all in centimeters or all in meters. We could do 60 centimeters is what part of a meter? Okay, either one, doesn't matter, but they have to be in the same units. So let me pause this right here. Okay, so remember, we're trying to get it all into the same units. So I either would do 48 meters, which would be the same as 4,800 centimeters, or 60 centimeters back to is 0.6 of a meter. I think I'm going to keep it as 0.6 of a meter. So that means if I'm looking at the graph of what's happening with this guy, and this is time, and let's keep the time in minutes because that's how it was displayed. The lowest you'll ever be on the Ferris wheel when you first get on at the lowest point down here is going to be 0.6 of a meter. That's the lowest you'll ever be. The highest you'll be would be when you rode it all the way to the top of the Ferris wheel, which is the 48 plus 0.6. So that would be the highest that you'd ever be, 48.6. So you start at 0 time, 2.8 minutes later, which would be, we'll just randomly put it there, you're going to come right back to the start again, because after 2.8 minutes, you've just ridden all the way around. So you start low, 2.8 minutes, you go around, you come back to the low again. So that means right here, halfway mark, 1.4 minutes, you're at the highest. Okay, so halfway on the ride, you're at the highest of the ride. So if I look at my graph, I'm going up, then I'm coming down, then I'm going to do it up, then I'm going to come down. So that's the ride of the Ferris wheel. So I know right now my max is 48, my min is 0.6. Once you have those two values, you should be able to find your A value, which is your max minus your min divided by 2. So 48 minus 0.6 divided by 2. So 48 minus 0.6 is going to be 47.4 divided by 2. So let's do that on a calculator so we don't mess up here. So we have 47.4 divided by 2 is 23.7. That's my A value. Okay. And then I'm going to do the D value, which is max plus min divided by 2. So that's going to be 48 plus 0.6 divided by 2. So 48 plus 0.6 is 48.6, divided that by 2, and you get 24.3. So now I have A, D, and B. And because it's starting low, it's not going to need a shift. I'm not shifting it anywhere. So let's write it as, and it's starting low, so that's a negative A. So negative 23.7, it's a cosine graph, the period of pi 1.4 for the B value, and we didn't have a shift, so it's just X, and then plus a D value of 24.3. So there's our equation, and it's asking us a couple questions. It says, find the equation, and we did that. Find the time intervals for which the rider is at a height less than 30 meters from time 0 to 2.8 minutes, okay? So time 0 to 2.8 minutes, it wants to know when the rider is less than 30 minutes. So less than 30 meters high. So the way that I'm going to do that is I've got to find out, first of all, where 30 meters is on my graph. It's somewhere in here. No, it's not that high. So it's somewhere in here. And I want to know where he's less than 30. So in here and in here, I can see it on my graph. But if I want some specifics, I need to graph it on my graphing calculator. So I'm going to put it on my graphing calculator. I don't know if you can see it. I am going to hit graph, and I'm going to enter it in, make sure I'm in radians. So negative 23.7 cosine, and then I'm going to do double parenthesis, pi over, so pi divided by 1.4, and then on the outside x, and then on the outside of that a plus 24.3. Okay, so here it is when I graph it. I don't know if you can see it. It looks kind of wonky because I haven't done a graph fit. So let's do graph fit. Let's do menu, window, fit, which is A. There it is. So there's my Ferris wheel. Starts down, goes up, goes down, and up. And I want to know what's going on when it's 30. So if I hit tab and I hit 30, for 30 meters, I can see that right in there, down below, is where it's going to be from 0 to something seconds. The quickest way to do it would probably be to find that intersecting point between the red line, I don't know if you can see it, between that red line and the blue curve right there. There's an intersecting point. So I'm going to hit menu, analyze graph, and I'm going to look for the intersection point. Okay, I'm going to go a little bit to the left of the point, a little bit to the right of the point, and I find the intersection point at 0.808. So when time is 0.8, let's round it off, 1, it's less than 30 meters. Okay, so from 0 seconds to 0.81 seconds. And then let's find the other intersection point, which is just right over there. Okay. Sorry about the howling cat. It's just what he does, she. All right, let's find that other intersection point. So we're going to go from there all the way over to there. And I'm finding another intersection point at, let's see if I can move it, 1.99, which is basically 2.0. So from 0 to 0.81 seconds, that would be the graph here. It's less than 30 feet. And then from 2, okay, 2 is about right here. This is 2. 2 all the way down to 2.8. It is also less than 30 degrees, or 30 meters. Okay? So that was the question it's asking. And then it's asking how many minutes does it take the rider to reach the highest point for the second time? Okay, for the second time. Well, we already know that it's a period of 2.8 minutes. So if it's 2.8 minutes for the low, it's 1.4 minutes for that highest point. That would be the first time. And then let's just go 2.8 minutes away to get to the next highest point. So next highest point would be 1.4 minutes plus a period of 2.8 minutes for a time of 4.2 minutes. So 4.2 minutes is when it's going to hit the peak again. Okay? So that's one problem I thought might be a little practice, so you can do that. Okay, so let me